Hello, everyone. Uh, this is Abhimanyu. It has been a very long time since I have uploaded my last video. So today, I have been busy in lots of work. Like I've joined EY Parthenon as a senior analyst, and I've been busy in lots of projects and lots of other things are going around. So today, I think that I'm going to upload this video. In this video, actually, in few of the projects, I have gone through a various multiple regression model. So those were quite complex. So I thought I should give some time over here and try to make, this small topic very useful uh, for everyone. Okay, so let's start just jump to our. So first thing we need to understand the data set. So this is our data set. Mostly like if you can see most of our independent variable like these are categorical, and our dependent variable that is salary is mm, um, simple a number, and the remaining two other independent variables. So this data is very clean, so I don't need, and it's very simple. So for training and for making to give some sort of idea, so this data is set is quite apt for that. Okay, so let's start. Let's jump to our Jupyter notebook. So here I have already uploaded and opened a new Jupyter notebook, and I have updated all the important libraries which I'm going to use. Pandas as a PD, NumPy as an NP, from stats model formula.api import OLS. So OLS stands for ordinary least square, which is a method for estimating the parameters in a linear regression model. Stats model is a library that provides classes and function for estimating testing statistical models like p-test, t-test. Okay, and there is other module that is uh, SciPy import stats, so that provide wide range of statistical functions. Okay, so these are some important libraries which we are going to use over here. So let's run this and let's load our data set. Okay, so pd df is equals to pd. Okay, so this is not working. pd.read csv. Let's copy our location of the data set. System is a bit slow. I'll try to do it faster. Okay. Dot csv to close this and this. We'll see. Okay, now let's display our data set. First 10 rows. Okay, it's quite good. And everything. Now let's check some information our data set. df dot info. Okay, let's run this. So it's very important to check if there is null. So as I already told, it's a very clean data. Okay, so all of our data type are good to run uh, one encoder and change our values into categorical into binary one. It's good. Now let's check df columns. Okay, now that is good. If some sort of variables in the like data type will be boolean, so what we used to do, we need to convert those booleans to object. But here we don't need to do anything. Now let's convert our categorical values into the binary ones. So by creating using the pandas, by creating by using the pandas, that is pd dot get dummies. So it's sort of one hot encoder that we use in scikit-learn. So that usually converts our categorical into the binary one. So let's do over here. Let's define our x. X is equal to x is equals to pd dot get dummies. Okay, this is not working. So let's copy this underscore from here. pd dot get dummies parenthesis df. Now I'll copy all of these columns except my salary column, because salary is going to be my dependent variable. Okay, let's remove the salary one. Yeah, and here we need to add one more thing, that is drop first, because the total, yeah, so this is all good. Now we'll do one small thing, uh, drop first is equals to true. I'll make you understand what is that. First is equals to, it's very case sensitive, true. Okay, now what is drop NA? Okay, so this code provide using the pandas library commonly used for data manipulation and analysis. So get dummies function of pandas to create dummy variable, so also known as one hot encoding, to convert like our categorical into the dummies one. And df dot drop first is, so this parameter is used to, I mean, avoid multi-collinearity issues that certain statistical model has, like linear regression. So by using this process, we convert our categorical categories. Let's There are k categories. We convert them into k minus one. Okay. So k minus one binary column for k categories. Okay. So let's run this. It's all fine. Okay. Now let's. So if you want to check, then x dot head, whether it is converted or not, x dot head, if you run this, now yeah, it has been converted. Every of our model has been converted. Everything is converted into the proper, like categorical values has been converted into the binary one. Now let's add a constant, because if we remember that in linear regression there used to be one constant, like if you recall our simple linear equation y is equals to mx plus c, add constant to capital X. So here also we need to add a constant. Oh, here we go. Run this. Yeah, it's working. Now let's define our y variable df df. Uh, what is our y variable? That is here. If we copy from here, it's a salary. Let's see, and post paste over here. Yeah, salary. Now let's run this. Now we are almost approaching to our last step. We need to define our stats. Yeah, we need to define our model. So uh, sm dot ols, that is ordinary least square, OLS, and y comma capital X, because that is our X variable, dot fit. Okay, now, okay, so there are two methods, like as per there are various other methods also, but generally two methods that has been used to find the multiple regression. So one is this one, and another one is using scikit-learn. So basic difference is scikit-learn is a bit complex than this. And here, I mean, you'll get, I'll show you, you'll get the summary in such a way. It's very neat and clean summary. But when you get summary in like your result in scikit-learn, there will be no, I mean, such sort of summary in over there. Okay. So this is one, I mean, a good thing about using this approach. Now let's run this. I'll show you the summary of our model. Okay. That will be very neat and clean and very systematic. Model summary. Okay, here. Now let's finger cross. Let's see how much is our r square, least and other variables. Okay. Here we, yes, yes. Look at this. Wow. Our model is perfectly fine. 99.7% r square and every variable f stats. Okay. So you can see how systematically it has presented the summary of our model. Okay. All the variables are over here. So best thing, we can easily copy this. Okay, and let's say copy, and we can paste in our Excel file. Let me go through our the things which I have done. So imported data, imported first libraries and data, then we did some information about our data set, and we created dummies by using like one hot encoding, then y variable, then we have fit the model, then we have printed the summary. Okay, that's it. Now let's copy this paste this summary in a sheet. Okay, we'll see. Oh, how good it is looking. It's a simple the way, I mean, when we used to learn our linear regression in the Excel, the both summary of both are looking almost same. Okay. Now R square is 99. Oh, almost. I mean, by looking at the data set, we can say that, yeah, this is a very good data set. I mean, nothing, there is no as in such outliers or other things that you cannot connect with them by just looking at the data set. Okay, so if we look at our variables, so age is a good factor because p is less than 0, and look at the coefficient. Okay, so this is affecting the salary, like, and if we look at other thing less than 0.05, okay, so this factor job administrative assistant. So yeah, so